Okay, we've been working on this example throughout the lecture notes, but now we actually want to do it in Excel. So here's our data. We've got our 40 data sets. We've got 4 different continents, so our factor with 4 levels, and then 10 observations for each of the 4 factors, giving us a sample size of 40. So let's reread our question. A transportation strategist wanted to compare the traffic congestion levels across 4 continents: Asia, Europe, North America, and South America. So we have this file. This is just containing the congestion level, defined as the increase in overall travel time when compared to a free flow situation for 10 cities in each continent. Okay, so let's start with a summary table just to get some summary statistics. Then we will fill out an ANOVA table, and then we'll finish with the Tukey-Kramer. Okay, so let's start with our sample size for each group, and we can see that there are 10 observations for each group, so we can just write 10, 10, 10, and 10. If you wanted to use a function, you can use count, so this would be equals count, and then highlight our observations and enter. You could do that for each one, and then for the total, so you could do equals sum and sum all of your sample size, so you get a sum of 40. And of course, if you ever need to see any formula in this, just open up the filled out version. So right now we're working in ANOVA and chi-square, so I recommend that you open this file and work through this like as we go. But if you want to see, I also have the filled out version, so if you ever need to see a formula, just click on the cell, come up here, and you can see in this bar the formula that's written there. So here it was sum K5 to K8, because I wanted to sum up all the individual sample sizes to get the full sample size. Okay, degrees of freedom for each individual continent. So this is just going to be equal to each of these minus 1. So I'm just going to drag this formula down by grabbing that bottom right box. And then our overall degrees of freedom is n minus 1. So that's going to be equals 40 minus 1, 39. Then we need to get our averages for each group. So that's our x bar j. And then we're going to do our variance for each individual group. So sj squared. So first I'm going to do the average for Asia, so equals average. I'm going to select Asia, enter, and then equals average. So if you see I'm not typing this whole thing out, once you see average, if you just click tab, it'll automatically fill. And then I'm going to select Europe, equals average, North America, and then equals average, South America. Now let's do variance. So let's do equals var dot s, and then I'm going to do Asia equals var dot s. We always do the s version. Europe, enter. North America equals var dot s, North America, and then finally equals var dot s, South America. And then we need the overall average and variance. So here I'm going to do equals average, but now I'm going to select the entire data set rather than any individual continent. And then I'm going to get the overall variance, so equals var dot s. But again, I'm going to select all 40 observations rather than just 10. Okay, so we've now filled out our summary table. Now notice I also have this C here for the number of groups, so this will just be equal to 4 because we have four groups. Okay, we're ready for the ANOVA table. So our sum of squares, we need to recall that it is the number of observations times the deviation between the overall average and the average for that particular group. So this is going to be equal to equals. So I'm going to take each sample size. So sample size times open parenthesis. So its average minus the overall average, close parenthesis, and I need to square that difference. And then we're going to do this for all of the others. So I'm going to add them. So actually, it might be easier if you look up here in the formula bar. So I'm just going to do the same thing over and over again. So I'm going to do Europe sample size times the difference in mean, so Europe average minus overall average, close parenthesis, square that difference, plus so the sample size for North America times the difference, so open parenthesis, difference between its average and the overall average, square that difference, plus sample size for South America, open parenthesis, average for South America minus the average for overall, close parenthesis, square the difference, enter. And naturally, I made a mistake somewhere. I forgot a multiplication. And I get 1172.48. Okay, now with the within group, you can actually just take the degrees of freedom and multiply by the individual variance and add those up. So I'm just going to do equals degrees of freedom times the variance plus degrees of freedom for Europe times its variance plus degrees of freedom of North America times its variance plus degrees of freedom for South America times its variance, enter, and we get 2259. Now again, you can kind of, whenever you're doing homework, if you just paste new data into here, this should all fill out more or less. You're just going to need to change, right? You're going to need to change the dimensions of each of these to make sure you're accounting for all of your data. And so this formula is kind of a pain to type out, but you can just copy paste it into your homework and then just modify it as needed. Okay, so total degrees of freedom. So we know that this is just equals. So I'm going to just do between group sum of squares plus within group, enter, and we get 3431. Degrees of freedom. So this is going to be n minus 1. So we already did that. So this was just equal to our total degrees of freedom, which was 39. Enter. Between groups. So this is c minus 1. So we have c right here. So you can just write 3 if you want, but I'll do equal c minus 1, and we get 3. And then within group, this would be equals n minus c. So that is 40 minus 4, or 36. And if you sum these two, they should equal your total, which they do. Okay. And now we are ready for mean squared error. So we know that mean squared error is just sum of squares divided by its degrees of freedom. So we can just do equals sum of squares divided by degrees of freedom. We get 390. If we do equals sum of squares divided by degrees of freedom, we get 62. And then our F stat is just MSA over MSW, so equals MSA over MSW. So we just divide the two, and we get 6.23. Okay, and then for our F distribution, our p-value, we can do equals F dot dis dot rt. So we're going to take our F value. So that was, this is kind of all in the way. So we can just type 6.23. Degrees of freedom 1 is 3. Degrees of freedom 2 is going to be 36. So c minus 1 and n minus c. Enter 0.002. And actually, instead of writing 6.23, I would rather reference this cell individually. So now if you look, it's the first thing I give it for the p-value is the actual f statistic that we calculated. The second thing I give it is numerator degrees of freedom, which is here. And then the third thing I give it is the denominator degrees of freedom, which is here, 36. And then f critical. So we're going to use f inverse dot rt, so equals f dot inverse dot rt. So probability is what, 0.05, comma, degrees of freedom 3, comma, 36. Enter, we get 2.87. So what's our conclusion? Well, we see that 6.23 is bigger than 2.87, so using the critical value approach, we reject the null hypothesis. So there's at least one difference in means. If we use the p-value approach, we see that p-value is 0.002, which is less than alpha of 0.05, and so using the p-value approach, we would still reject the null hypothesis. So again, a lot of these formulas, if this confused you, you can always see what I wrote by just coming up here and seeing exactly what's in here. But with all of these written as functions, like whenever you update these tables, these things should just update automatically because the p-value is just referencing other things in this table. Okay, so it's because we rejected the null hypothesis, we now move on to the Tukey-Kramer procedure. So one thing we need to do is get our Q value. So recall we needed this studentized range distribution with 4 and 36 degrees of freedom. So that's C and n minus C degrees of freedom. So to get this, I recommend just use the internet. So go ahead, just Google studentized range Q table calculator. If you just Google this, and then I just found this very first link to work. And actually, you can do this for all of the distributions if you want. Some of these calculators are online are actually really easy to use. But how about we just click on this first one? All I had to do is just give it the degrees of freedom. So what was it? We had 4 for numerator and 36 for denominator. And then if I just say calculate Q critical, it gives me 2, one for 0.05 and one for 0.01. Alpha is 0.05 for us, so we're going to use 3.81. So let's do that. I'm just going to write 3.81 here for our Q value. Okay, absolute difference. This is just the absolute difference between all of these. So we just do equals abs, and then we take the difference. So Asia minus Europe, enter. And I'm just going to keep doing this. So equals abs, so Asia minus North America, and then equals absolute value, Asia minus South America, and then equals absolute value, Europe minus North America, and equals absolute value, Europe minus South America. And then finally equals absolute value, North America minus South America. Okay, so now we're ready to calculate our standard error, which was, if you recall, it's the square root of our MSW over 2 times 1 over n plus 1 over n from each of the groups. So let me just do this piece by piece. So let me do equals. So let's go ahead and take MSW. So I'm going to click here. Now I'm going to go ahead and lock this in. So I'm going to do a $sign in front of the M and a $sign in front of the 14. Now I'm going to divide this by 2 and wrap it in parentheses. Now notice I'm typing up here to make my life a little easier. Okay. Times. So I have 1 divided by 10 plus 1 divided by 10, because all of our sample sizes are the same. So I just do 1 over 10 plus 1 over 10, and then I take the square root of this entire thing, and I get 2.51. And then I'm just going to drag that down. You could also just copy paste it down. And then our critical range is just going to be our standard error times our Q. So equals standard error times Q, enter, 9.54. Now let's drag that down. I need it to lock in the U value. So up here, this U1, I'm going to lock with the $sign. So $U, $1. And then I'm going to drag it down. Okay. And now I'm just going to write a little function. So all we have to do is if this is bigger than this, then the means are different. Otherwise, they are not different. So I'm just going to write equals if, and you don't have to use this function, but I'm going to say if this minus this is bigger than 0, then I want to say means are different. Otherwise, means are not different. And then I can drag this down. And there we go. These are our two groups. So we can see that these values are bigger than these values. And again, you can just reuse all of these functions that I've made. You'll just have to be really careful updating all of them, making sure they're referencing the right cells so that you can just go ahead and recycle it. One thing I forgot to do, I'm sorry, this is something we should have done at the beginning, which is to create a box plot. So let's go ahead and highlight our data and do insert, come over here to box and whisker, and we get our chart. I'm sorry, that should have been the first thing we did. So let me go ahead and title this. So traffic congestion by continent. And then I'm going to go to chart design, add chart element. I want to give it a legend so I can actually see which one represents each continent. We don't need this bottom axis. And if I wanted, I could add a vertical axis label. This would just be traffic congestion. Okay, so that's our problem. So if we, again, just kind of come back to our box plot, we can see that Asia is bigger than the others. These three didn't look all that different from one another. We would check our assumptions, so we noted that these are somewhat symmetric. The variances are relatively equal to one another. We know that they're independent from one another, so we checked all of our assumptions. So that's really important to check those. Make that bold, doesn't really matter. And then we went through, we filled out the summary table. Then we filled out our ANOVA table. We saw that we rejected the null hypothesis, so we knew that there were differences somewhere. And then we moved forward with the Tukey-Kramer procedure to see which means were actually different from one another. And we saw it was Asia to North America and Asia to South America because their difference was bigger than the critical range. Okay, so that's the entire process. Hopefully you can recycle all of these formulas to make your life simpler for the homework.